I'm here in the financial center of London, ironically, talking to Marcell Tessenyi, who is the CEO of Blue Sky Space Limited, correct, Marcell?
That's correct.
A space startup that you would never expect to be in a incubator situation for for-profit companies, I guess many of which are high-tech
Right.
companies.
A lot of software as well.
A lot of software. But Blue Sky Space is actually wanting to commercialize, or in the process of commercializing, the taking of observational data from spacecraft in a way to make it profitable. It's a for-profit company, correct, Marcell?
So that's correct. We aim to use the benefits that a commercial approach can take to really develop and deliver in an agile way, in a very rapid manner, a supplementary fleet of satellites to complement the valuable work that's been done by the space agencies. But by taking a commercial approach, we can actually take quite quick decisions and have a very effective procurement model that allows us to deliver scientific satellites at a very cost-effective price point that allows us to make this data available to as many users around the world as possible.
And you yourself are an astrophysicist who was previously at University College London, and your co-founders are also academics, but you saw an opportunity to maybe serve the community in a way that heretofore I can't say that I know of any other company quite like yours.
That's right. We understand that the demand for data, for scientific data sets from satellites is far greater than ever. There is a demand at a global level, and we hope that the model that we're developing here will allow us to really supplement what's out there already today and really increase the participation of institutions around the world in the global space research community.
And your first satellite is a smaller satellite, but the satellite that we've been discussing is Twinkle. Tell us what Twinkle would be and when you think it might launch and what its targets might be.
So the Twinkle space mission is a low Earth orbit, 400 kilogram class satellite that has a half-meter class telescope coupled to an infrared spectrometer. And it's a satellite that has been designed to primarily study the atmospheres of exoplanets, of far, far away objects, far away stars. And it's a satellite that will be launched at the end of 2024, will start operations early 2025, and will be delivering data sets on hundreds of exoplanets, but also their host stars, and also solar system objects such as asteroids and comets.
And your first satellite that's going to be launching is a different satellite, and it's called
MOVE.
MOVE, that's correct. And it's targeting, it's going to be looking for exosystems, correct?
So the MOVE satellite is a smaller format spacecraft. We're talking about roughly a 15 centimeter class telescope in a smaller format satellite, also going into a low Earth orbit. And this one has been designed to carry out UV spectroscopy, primarily of stars, to monitor the activity of stars, many of which might be hosts to planets. And the activity of these stars might have a disruptive effect on the potential habitability of some of these planets. And that's what we'll be focusing on with the MOVE spacecraft.
So MOVE will not be detecting new planets; it will be monitoring, doing photometry of the stars,
of the host stars,
to see how effective, how hospitable they would be for potentially habitable
whether
planets.
The activity of these stars and the flares that come out of those stars might have an impact on the planets which are hosted around these stars.
So what has been, I guess you never envisioned 5 years ago that you would be doing such a venture. What has been the most surprising thing about attempting such?
So it's a phenomenal journey to have embarked on this. It took us quite a while to build up the credibility that what we're embarking on, which is quite radically different to the current model, the way the current satellites are being delivered for space science. And we probably didn't know the scale of the task we had in front of us for addressing those points of concern and making sure that people become fully aware and comfortable with what we're doing as a model and the data process we're delivering. But I'm tremendously delighted, let's say, by the traction we've gotten so far, by the support we got from the various agencies, by the support we got from the scientific community, and of course of all of the financial backers that we've had so far.
So thank you so much for your time today. We look forward to following the progress of Blue Sky Space. Thank you, Marcell.
Thanks so much.